Hello students, hope you all are doing well. Here in this video, we are going to find out about functional groups that you find in organic chemistry. What are functional groups? Functional groups which are functioning, they are within organic molecules. Let's find it out. What exactly these functional groups are that you find within organic molecules. So, let me give you this molecule with 4 carbon and no double triple bonds between carbons and having hydrogen. So as we have so far looked at these kind of molecules, this belongs to the category of alkanes. We identify these kind of substances as alkanes, not seeing any carbon-carbon double bond, carbon-carbon triple bond within the molecule. So, if you find any such, they are within the molecule. Let me give you another one having the same 4 carbon. But in this, I am going to give you a double bond between 2 carbons. This is another similar molecule, organic, hydrocarbon molecule. So it's because you have carbon and hydrogen only within the molecule, and here at this time it's you are having this thing being special. This is carbon-carbon double bond. Seeing that it will identify it as an alkene. So similarly, when you find something like a carbon-carbon triple bond there, it's just for the reason you have a triple bond between 2 carbons, it will call that an alkyne. So here within this molecule you can't see any such special. This hydrogen, when you take one hydrogen, this hydrogen you take, this hydrogen is there. It's important to represent the molecular formula C4H8, the presence of this hydrogen. Other than that, this hydrogen is not very special something. So, but compared to that, this carbon-carbon double bond is special. Compared to that, this carbon-carbon triple bond is special. But this each carbon-carbon single bond is just there. So, those are not that special as you find these double triple bonds. Further, if I give you another one, it's 1, 2, 3, 4 still. If you are having a chlorine atom, so when you compare that with the very first molecule, what's the very first molecule? It's this. So this position of hydrogen was now occupied by chlorine. One hydrogen there was substituted by the chlorine. So then it's when you look into this molecule, it's you would find this chlorine. You would notice this chlorine is there. So it's special. Then just having this hydrogen, when you just look at the molecule, will you notice that this hydrogen is very special as you did it on this atom? In that manner, even in your classroom, you would find some students being kind of more special. I'm not telling clever only. For sometimes they might be notorious at something. So might be maintaining the goodwill of the class. When we imagine about a class, so it's if you have such a fellow there, it's we quickly notice the class. Is the class with that fellow. Okay, I'm not giving the idea that it's very bad or very good or something. It's not all about good and bad. Students, sometimes within molecules, you would find such special atom or gathering of atoms with few atoms. Sometimes it could be, another example, it could be a gathering of atoms. It's a group. So having of such gives special properties to the molecule. When we again go back to the examples, this is just for butane, it's an alkane anyway, but this is butene, this is butane, the position of carbon-carbon double bond here on the second carbon, the triple bond you get. Then here on the second carbon you have chlorine atom, so it belongs to the category of alkyl chlorides. So this is having OH group, so we call it an alcohol. Anyway, what's the big deal? Having of those such differences. Students, it's not just we can see those, but having of such different gathering of atoms or just one atom, they give special features, characteristics, chemically, physically, in both aspects. So they control the molecule, means they make those molecules chemically and physically different. Such species, such an atom or few atoms, gathering of atoms, let's call groups, are referred as they contribute to the function of the molecule more in a greater percentage. So we call them functional groups. Those are the functional groups that you could find out within organic molecules. Hope you could understand. Being there within a molecule, expressing or giving more chemical and physical different features. Different means sometimes it could be responsible for inertness of the molecule. For sometimes it could be kind of controlling the molecule as it's more reactive than earlier, having that functional group there. So therefore they would decide what kind of molecule it is, giving different properties, different chemical properties, its physical properties as well. They have different boiling points, having these different functional groups there. So that's the idea of having a functional group there. Students, therefore, a functional group is a group or atom, one atom, means it's a gathering of atom or one atom, we'll call it a group, that you find there within the molecule controlling the properties or giving more contribution to the to express of physical and chemical characteristics within the molecule. So those are the functional groups. Here in this video, what's our duty or what's our effort is to show you such few functional groups, to introduce you some functional groups. Let's find it out some functional groups that you could find out within organic substances. Okay. Then students, as you have seen that when you have just an alkane, we don't call it carbon-carbon single bond within the alkane molecule as a functional group. But when you find a carbon-carbon double bond, it's this part we identify it as a functional group because it could make that molecule react differently. That molecule to express its physical characteristics, melting point, boiling point, specific heat capacity, such, as well as its reactivity, chemical characteristics differently. Therefore, having of an alkene CC double bond group is a functional group. Then next we have already found out alkenes in a series in alkenes family as ethene, propene, butene, pentene, hexene, heptene, octene, nonene, decene. For the first time alkenes, we looked at those. So therefore, it's just I'm going to mention this having of carbon-carbon double bond. It belongs to a one category, one functional group category. Okay. Then similarly, having of a carbon-carbon triple bond also important. It gives different properties to the molecule. Therefore, that also is a functional group. But if we have already talked about those, naming them as alkynes. When you find a carbon-carbon triple bond, we call it an alkyne. So, we talked about the first 9 alkynes in the family. In the series, it was ethyne, propyne, butene, pentyne, hexyne, heptyne, octyne, nonine, decyne. We identified them with the suffix YAB, ine. So we talked enough about those alkynes within the alkynes functional groups family. Okay, then it's now we are going to talk about the next functional group. Students, when you have an alkane, let's take the simplest alkene. It is methane. When you have one hydrogen being substituted by a chlorine atom to the position of a hydrogen, if you now have a chlorine atom, it could be even bromine atom, fluorine atom, iodine atom. What are they? Those are halogen atoms. When you find a halogen atom, let's denote them with X, then this is an alkyl group. When you find an alkyl group bearing having a halogen atom, we call them alkyl halides. So this example, this alkyl group is methyl, then this halogen is chlorine, so it's chloride. It's the methyl chloride. So you could talk about some other alkyl halides as well. So when you have ethyl groups with 2 carbon, we call it ethyl. Then students, when you have ethyl group with another halogen, let's say it's bromine, it is ethyl bromide. You could denote it in the form of C2H5Br as well. So this is CH3Cl. So when you talk about propyl, the alkyl group, it has to be having 3 carbons. If it is this propyl, N-propyl, normal propyl, then let's call it iodide. It's propyl iodide. But it could be not on that carbon, but on this carbon, this iodine atom. Then students, look at this. It's on this carbon that you have got this iodine atom attached. Is a carbon here you have. On this carbon, you have 2 CH3 groups attached and 1 H. On a carbon, when you get 2 methyl groups and 1 hydrogen atom being attached, that whole part is referred as an iso species. Therefore, in that aspect, this whole part is carrying 2 of methyl groups and 1 of hydrogen attached to that. Then it's an iso. In this iso you find 3 carbons. It's isopropyl. When you have iodine there, it's isopropyl iodide. That also a propyl, but it's not normal linear chain. This is normal propyl, or simple N we use to say normal. In applications we identify them as that manner. So those are trivial names only. So it's normal propyl, N-propyl iodide here. Then this one is isopropyl. Iodide. Likewise, you could have various alkyl halides. So those are students alkyl halides. Then let's talk about the next category of functional groups. The next category is when you have O being surrounded by 2 alkyl groups. This is one oxygen atom got attached to 2 alkyl groups. These 2 alkyl groups could be same, means if this is methyl, this also could be methyl, but those could be varied as well. So then we call them ethers, alkyl ether. Okay, let's find it out. when you have methyl group here and other side also methyl group. This is a methyl ether. Methyl, it's you repeat the same. So we call it dimethyl. This ether is called a dimethyl ether. It's the dimethyl ether. So when you have ethyl other side, but here methyl, it's ethyl methyl ether is the name. Ethyl methyl ether. Those belong to the category of ethers. Then when you have another one, CH3CH2, it's an ethyl. CH2CH3, it's also is an ethyl. It is ethyl ether, therefore diethyl ether. Then students, when you are having such like CH3CH2 is a propyl, and other side, if you have propyl but in this form, it is on the same carbon you have two alkyl groups, methyl groups and one hydrogen. It is isopropyl. This is normal propyl. It is N-propyl isopropyl ether. So let me give you another different one. It's you are having on the same carbon two methyl and one hydrogen. It's an iso structure. Then it's not anyway 3 carbon, it's 4 carbon, therefore it's isobutyl. It's isobutyl, so you could make it CH2, 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 CH3. It's normal butyl ether. So you just could change these alkyl groups, substitute various possible alkyl groups. Then those would be accordingly alkyl ethers unless they are the same alkyl group. Then it is dialkyl ether. Okay, those are ether groups. Ethers are quite different from other organic substances. Ethers remain as non-polar substances at most of the time. So most of ethers serve as solvents, media for those organic reactions. We would be talking about the dry ether medium without having any moisture, water there. Okay, those substances are called ethers. Then let's talk about another type of functional groups. So students, my next type, they are, I'll take it as having alkyl group with an O, and at the other end it's not another alkyl group as well as in ethers. But here at this time it is a hydrogen you have. So then its students, we call them alcohols. These functional groups are the alcohol groups. Okay. Then the simplest alcohol, it is when you have the simplest alkyl group. Its students, one carbon is the alkyl group, so it's methyl. It is methyl alcohol. Okay, methyl alcohol, you could name it as methanol as well. It's methanol. Then next alcohol is when you have this alkyl group, it's ethyl. It's ethyl alkyl. It's ethyl alcohol. So it's called ethanol. Ethanol. It's the favorite alcohol of some fellows. Okay, so next one is propyl alcohol. It's propanol. Oh, it's normal propyl alcohol. So next one is when you have it being propyl but OH come here. So it's isopropyl alcohol. Isopropyl alcohol is the one you use as a substituent to disinfect those surfaces, wounds and such. So when you check that bottle that you call surgical spirit, it might have mentioned there in the label as isopropyl alcohol for surgical spirit. So earlier in surgeries they use ethanol as to disinfect the surfaces. So as the surgical spirit. But then after they have substituted that with isopropyl alcohol. That's why we call it isopropyl alcohol for surgical spirit. Okay. Then students, methanol. Methanol is for us, it's toxic. Methanol is highly toxic substance. When you drink methanol enough, you would die at the same place. So it's for the reason that you die on the spot, it's called here ethanol, right? Methanol. Okay, when you talk about ethanol, people they enjoy ethanol thinking that they would then feel that dopeness. So then it's after consumption ethanol for long period of time, they would have their body organs being malfunctioning, especially liver. So they would start suffering from the disease called cirrhosis. Then it's they would then suffer a lot and die over there. So it's ethanol, right? So then anyway, this is the alcohol that in those alcoholic beverages found. But when you find this being contaminated with such beverages, it makes toxic. It brings toxicity. Having slight amount of methanol there, consuming that, it causes the loss of eyesight. So then those are the stuff regarding alcohols. So students, we could talk about butanol, pentanol, hexanol, heptanol, octanol, nonol, decanol. With increase of the carbon chain, the polar character, as well as their miscibility with water also would be affected. So anyway, when you find this functional group, we call them alcohols. Then let's talk about another functional group. Students, the functional group that you have, before saying that, let me show you this. This is called ammonia. When you have one hydrogen being substituted by an alkyl group, it's called a primary amine. Primary amine. For an example, this. It's methylamine or methanamine. Methylamine or methanamine you could call it. Then when you get two of those hydrogens being substituted by two of alkyl groups, it's a secondary amine. Secondary amine. For an example, it's you could take either same alkyl group, then it's methylamine, or when you say methyl, when it is the same, you could say it's dimethylamine, or ethylmethylamine, methylpropylamine. You could play with, you could change the alkyl group accordingly. Then students, when you have all three hydrogens being substituted by alkyl groups, it could be either same or different. Then it's a tertiary amine. So when it's a tertiary amine, it would have three alkyl groups around nitrogen. Those could either be the same or different. It doesn't matter. It's not a big deal. So it's methyl amine. It's trimethylamine. So ethyl dimethylamine, ethylmethylpropylamine, ethylpropylbutylamine, ethyl isopropylamine. So various different alkyl groups you would try substituting there. So you would get different tertiary amines. These all belong to the category of amines. They are called amines. Amines also is another functional group. So students, that's what we have got there as the next functional group. So let's find it out a different functional group. When you have a carbon bearing a double bond there, students, we could call it the group a carbonyl group. It's a carbonyl group. So when you have a carbonyl group with an alkyl group at one side and just a H other side. In this category, this also could be a H. So this type is referred as aldehydes. Aldehydes. Then students, when you have the other type of carbonyl compounds, both could be alkyl groups. Then we call them ketones. Ketones. So let's talk about some examples. When you have this aldehyde, the simplest aldehyde with no more carbons other than of this. So it's the first member. So it's called methanal or methanaldehyde. Then students, when you have one carbon there within a substance, we use the sound form. With that, it's called formaldehyde as well. Formaldehyde, methanaldehyde are the names. This is well miscible with water. So this is used to preserve those tissues, especially when those are required to keep for long period of time. So a mixture of water and formaldehyde is referred as formalin. Is used in embalming. Okay, so then it's the first aldehyde. Then the second member. Students, when you find two carbons, it's the sound we use acid. Acid sound is used for two carbons. So it's the second aldehyde, ethanaldehyde, or ethanal you could call. We give the suffix al on aldehydes, ethanal or ethanaldehyde. With the sound acid, you could call it acetaldehyde as well. Okay, next one is with three carbons. It's students propanaldehyde or propanal you would call. So accordingly, you could go ahead as butanal. Pentanal, hexanal, heptanal, octanal, nonanal, decanal are the first 10, let's say, aldehydes. Then students, it's having the carbonyl group. The other type of carbonyl compounds these two types are called aldehydes and ketones are called carbonyl compounds. So then within the carbonyl compounds, the first type we have already discussed about the aldehydes. Next is the ketones. Which tones? Ketones. Then students, when we talk about ketones, it's a must to have two alkyl groups at two sides. They could either be the same or different. So this is methyl ketone. Methyl, same repeating. So you would call methyl ketone. And it's dimethyl ketone. There is another name standing for that is propanol. So this having these two alkyl groups with a carbonyl group, it's a ketone. So other than this carbonyl group, the number of carbons it's having is 2. 2 is pronounced as acid. It's acetone. Another name, it's a trivial name. Acetone is a well-known solvent used mostly in organic reactions as a solvent. So then it's acetone. Another one, if you could have ethyl here and ketone group. It's a CH3. It's ethyl methyl ketone. Ethyl methyl ketone. Or you could call it butanol as well. Then students, you could have diethyl ketone, pentanone, so propyl methyl ketone, so ethyl butyl ketone, various different ketones playing with these alkyl groups. You could try for different ketones changing these alkyl groups. Okay. So aldehydes and ketones are called carbonyl compounds. Carbonyl compounds. Then students, the next type we are having is alkyl cyanides. Alkyl cyanides. What are cyanides? Cyanides are having CN groups. When you have an alkyl group there, it's alkyl cyanide. So it's a triple bond you have between carbon and nitrogen. So it's the alkyl cyanide. You can't have an H here. It is a must to have at least one carbon. So the first member here is this methyl cyanide. Including this carbon, you could call it acetonitrile as well. Acetonitrile. Nitrile is the suffix given when you name those alkyl cyanides. Let's find it out in nomenclature part. Listen nomenclature. Okay, students, next one is it's CH3, CH2, Ca. With ethyl, you would call ethyl cyanide or propylnitrile is another name. So it's CH3, CH2, CH2, Ca. It is either propyl cyanide or including this carbon, it's butanitrile. So are the cyanides alkyl cyanides? Okay, the next type of functional group that we have got in our list is carboxylic acids. Carboxylic acid functional groups would be such when you have carbon with two oxygens, as one is having a double bond with carbon, other is having a single bond, next to that there is a H. So these kind of groups are called carboxylic groups. So these groups exhibit some sort of acidity. They could lose this hydrogen at the next time, forming COO minus ions. Therefore, these are the acidic substances that you would find within the organic molecules in organic chemistry. Therefore, we call them carboxylic acids. Okay, it's when you have an alkyl group, this alkyl group here would be even a hydrogen. So it's the simplest carboxylic acid. Or it could be a methyl here. So it's the second carboxylic acid compound. So you have there. So in the category of carboxylic acids, you have this be the third. Students, in this way you could increase carbon number. So it could be having a hydrogen as well. So it is one carbon containing carboxylic acid. There within the molecule you would find two carbon. Within the molecule, three carbons you would find. So these carboxylic groups could be sorted as when you have carbon and two oxygen and hydrogen, it is the carboxylic acid group. You could further give it in the form as of CO2H. Then students, the very first member within the carboxylic acid family is having one carbon. It ends with the sound oic acid. So it is methanoic acid. The first member is named as methanoic acid. Methanoic acid. Then the second, accordingly, second having two carbon. So it's ethanoic acid. Ethanoic acid is the name. Acid. Then this is propanoic acid, butanoic, pentanoic, hexanoic acid, heptanoic, octanoic acid, monoic acid, decanoic acid. In that way, you could have 10 members within the carboxylic acid family. First 10 members. So it's when you take acid in applications. So this methanoic acid is having quite sour taste. Students, you could find this methanoic acid in nature being there inside the abdomen part of that ant-like creature called Amblia. Hope you have seen. Okay, those at most of the time live around those sugar bottles and such places. So mistakenly, when you find those being dumped there inside those tea or plain tea or such, so it's when you take a sip inside, mistakenly I am telling this, when you take that creature in your mouth and when you crush that, you would have felt this sour taste. That's what formic acid or methanoic acid. So having one carbon, we could use the sound form. So and call it formic acid as well. The same methanoic acid could be named as formic acid as well. It's a trivial name. Then this is having two carbon. Two carbon could sound as acid. So when you sound it as acid, it is the acetic acid. It's the acid you find there in vinegar. Okay, so propanoid, butanoid, pentanoid, hexanoid, heptanoid, such various carboxylic acid compounds you would find out. Okay, then it's when we go for the next type of functional groups, it's those other functional groups I'm going to show you are derived from these carboxylic acids. What's that mean? These other groups going to have some other various different parts here for this being attached. Therefore, we call them acid derivatives. It's when you have carboxylic acids OH being substituted by these groups that what I am going to give you now, those are called acid derivatives. These are acid derivatives. So it's for the position of OH, they have got another group being attached, another part being attached. That part, let's name it as A. A could be either an amine or either alkoxide part or a halogen part, halogen atom. So accordingly, you would name those when you find it being a NH2. This H could be even an alkyl group as well. So then we call them amides. Amides. Students, when you find those being the carboxylic acid that OH being substituted by this OR group, it's we call it alkoxide. Then students, it's we call them esters. Next, when you have those being substituted by halogen atoms, let's say halogen, halides, chlorides, bromides, iodides, so those could be, we call them acid halides. These are the acid derivatives we have got in our syllabus as to talk about. Then further, it's a bonus one. You could have this kind of one as well. This also is an acid derivative. This is called acid anhydride. Okay, those are the types of acid derivatives. Again, when you find the OH group of a carboxylic acid being substituted by another part like these, those belong to the category of acid derivatives. So there are amides, esters, acid halides, and anhydrides as well under the category acid derivatives. Out of those categories, let's first find it out the amides. Okay students, when you talk about amides, you already know you would have this H and this is is the very first amide that you could find. And having one carbon more, there are another amide and another amide with further one more carbon being attached there. So then you would continue giving more carbon, increasing the number of carbons there. Students, the very first amide having one carbon there is methenamide. We name it as methenamide. Methenamide. So one could be found with form. So then it's formamide. You could name it as formamide as well. Then it's with two carbons. You could call it with two carbons. It's ethanamide. So two could be sound like acid. Therefore, it's acetamide. Another name, trivial name standing for that. Then this is with 3 carbon propanamide, with 4 carbon butanamide, 5 pentanamide, 8 octanamide. In that way, you could find out various amides. So it's not only these kind of amides you could find out. It's possible you to have amides having these H's being substituted with further alkyl groups. This also is an amide. Its name, let's consider that in IUPAC nomenclature is a lesson, is a part we have there within organic chemistry that we are going to name those compounds according to their number of carbons and functional groups found there within the molecules. So let's name them in our that lesson nomenclature part. Okay, anyway, this also is another type of amide. When this hydrogen, that hydrogen is possible to be substituted with an alkyl group, then this also could be substituted by another alkyl group. Then it's another amide you get there. So likewise, you would talk about amides when this position that earlier OH was in carboxylic acids being substituted by NH2 group there. Then our next functional group, acid derivative, is let's talk about acid halide next. Acid halides. So students, as you already know, when the OH group you have got here being substituted with an it's a halide, its halogen atom could be fluorine, chlorine, bromine, iodine. Then we call them acid halides. So this R could be a H as well. Is the very first acid halide you get. It is one carbon. So acid halides are named in the form as with the suffix oil halide. So it is methane with one carbon. So methanoyl fluoride. Its name is methanoyl oil halide. Fluoride here. So then when you have one more carbon added, it's now 2 carbons. So it is with 2 carbons, it's ethane, ethanoyl, chloride now at the moment. It is chlorine atom you have got. So you could have accordingly further acid halides increasing the number of carbons as well as changing the halogen atom you have got. It is from 3 carbon, propane, propanoyl, bromide you have got here. In that manner, it's butanoyl iodide. So such various acid halides you could have. These students, at the very first, it's you could sound this like form when you have one carbon. It's a formyl fluoride. You could sound this with 2 carbon as acid. So it's acetyl chloride. Propanoyl bromide, such you would have. Then consider their chemical characteristics, you could find these acid halides are quite unstable. They could readily react with water, even moisture in air. So then you can't store these acid halides for a long period of time, because when you open the bottle or when they get exposed to air, those could react with the moisture in air. So reacting with water, those could get transformed into respective carboxylic acid. These are highly reactive organic substances that you could find within organic molecules. Okay, our next category of functional group students is esters. Esters. Let's find them out. Esters. When you talk about esters, it's a carboxylic acid derivative. Now the OH group has been substituted by OR. We call that part alkoxide. So these are in formation of esters. Esters are formed when alcohols react with carboxylic acid. So this OR part, in that the origin of OR part is an alcohol. So this OR part is coming from an alcohol when you talk about its origin, the synthesis of an ester. So this part is coming from a carboxylic acid. Therefore, we call this alkyl group as an alcoholic alkyl group. Well, so then we name this at the last, this part with the suffix OA, and we name this alkyl group first. Is how we name these organic substances named esters. So this alkyl group as alkyl leaving a space. We then give the, according to the number of carbon, we then give the name with number of that carbon. So, and finally we end that with the suffix OA. So we'll discuss an example like this. This is an ester. This is an ester. Here at this end you have one carbon, at the other end you have another carbon. So this carbon has come from origin from an alcohol. So it is first mentioned as one carbon alkyl is methyl. It is methyl. Then leaving a space we give the number of carbon here is 1. So it is 1 carbon is met, then methane, methanoate. Methyl, methanoate. Methanoate is the way we name that. So we would be discussing about this in our lesson nomenclature in more details. So students, it's when you find this being the same, it is methyl CH3, but this has got increased by one more carbon. So then we still say it is methyl. Then it's 2 carbons you get there. It is ethanoate. Then let's leave it as 1 carbon still you are having, and the other side as CH2 CH3 will increase the number of carbon there by 1. Then students, you could have this being ethyl. First you mentioned that ethyl. This is with 1 carbon methanoate. 1 carbon in application with the sound form. Therefore, you could name it as formate. So another name standing for the same. It's methyl formate. Methyl form. So this one methyl, but 2 carbons sound as acid. So methyl acetate. Then this is ethyl formate. Ethyl methanoate could be named as ethyl formate as well. So you could change the number of carbon here as well as there and have various such esters. Another thing regarding esters. Esters in organic chemistry that we find, the substances are having decent odors they could be found in those fragrances. So then those are having nice smells, decent odors. They are in esters. From those ripening fruits, the smell spreading all around, that pleasant smell, mostly caused by esters. In perfumery oils, you would get esters. Okay, then students, those are the stuff we have got regarding those acid derivatives. Then we are going to round up here in this lesson regarding functional groups. If we are going to meet you in our next lesson talking about aromatic substances. Okay students, goodbye.